Carol, you got anything you want to add? You're muted, Carol. You were muted, Carol. We couldn't hear you.
Oh, I'm sorry. I thought I'd hit the key. I'm fighting laryngitis, so I will use sign language as much as possible and save you all from having to listen to my croak.
Awesome. We want to do a roll call, Joe?
Yes, please.
All righty.
Councilmember Edens, Member Bartlesmeyer, Member Delante, Member Sturman,
Here.
Member Berger,
Here.
Member Patton,
Here.
Member Brayman,
Here.
Member Donaldson,
Here.
and Co-Chair Holthouse. It's here, and Co-Chair Farmer.
Here.
Thank you.
All right. I don't see any other attendees, so I assume nobody wants to say anything. So we can just move on, I guess.
Mr. Chair.
Oh, yeah, go ahead.
Yeah, Joe, did you mention, I didn't quite hear, and you asked Carol if there's any other issues one would like to bring up in the meeting?
So I was just going to see if anybody wanted to make any comments about anything going on. So you can certainly do that, or we can save that at the end if it's a little miscellaneous thing.
save
Whichever
it.
you
Yeah,
Okay.
sure. Thank
Cool.
you.
Mr. Bunich.
Minutes.
Yes. If we can, we need to approve the minutes from our last meeting, which was all the way back at the end of November. So if anybody would like to make a motion to approve the minutes, or if anybody has any questions or concerns, you can raise them now.
Move to approve. So move.
All right, Mr. Patton and Mr. Sturman. Thanks a lot. All right, all those in favor of approving the minutes, please say aye. Aye.
Aye.
Anybody opposed? And any abstentions? All right, very good. No comments. So up first, I guess we've got our USGS report. Mr. Vunich.
Thank you, Mr. Chair. Mr. Chair and members of the task force, as you know, approximately 1 year ago, a contract was signed with the United States Geological Survey to do an extensive study of Cox Creek and certain portions of it. It's not the entire length of the creek or the entirety of the watershed, but certain key areas. As I mentioned, it's been about a year, and Dr. Jessica Leroy is with us tonight, and she is going to provide a presentation that I think will be very informative to the task force members, and also just kind of give some thoughts as we enter the second year of the study. And so with that, I'll turn it over to Dr. Leroy. And as I say, she'll be sharing screen for her presentation. One last thing before Dr. Leroy begins is just that we do apologize for the kind of unusual nature of tonight's meeting. We did try to fix the projector today so there wouldn't be the purple hue. We were unsuccessful. So thank you for your flexibility in this regard.
Okay, thank you, Joe. I think you can see my screen now. All right, so I'll go ahead and get started here.
Yes, ma'am.
Great. So as Joe said, this is just kind of our mid-project update on the project we started last year. So just to kind of go over, come on, it's not going. Hang on, technical difficulties here. My slides don't want to advance. There we go. So to go over the objectives of the project, there's kind of two main sides to it. There's our field monitoring side and the modeling side. So the field monitoring side involves monitoring bank erosion at a few key sites that were identified based off of the work of Dr. Hammer and some of the materials that were provided to us by the WETF. And so the main method for this is using a terrestrial LiDAR system. That's a laser scanner that gives us a very high resolution, three-dimensional picture of the riverbanks. And so the other side of the project, the modeling side, involves both hydrologic and hydraulic modeling. So the difference between those two things, the hydrologic modeling basically refers to a model that takes rainfall and turns it into stream flow. So it's modeling the processes that occur when rain hits the land surface, and how does that water get into the stream. And then the information from the hydrologic model is used to drive a hydraulic model, which gives us more detail about the flow of the water in the river, including water surface elevations, depths, and velocities, which can be used to compute some important parameters for understanding erosion, like shear stress. And so we are doing that kind of modeling for both current and projected climate change-based precipitation, and also looking at the effects of added storage. And then finally, the last little modeling piece is to do some bank stability modeling at 4 sites. And this is kind of contingent on the results of the hydraulic model. So that's kind of the scope of the project, just a bit of a refresher. So looking at that scope as kind of a checklist, for the monitoring side of things, our year 1 data has been fully collected, of course, the year's over, and we are well on our way through the processing of that data. And so we are also now gearing up to do our year 2 data collection. So we're planning on coming out in the late February to get our first LiDAR scan of this year. As far as the modeling side of the study, the hydrologic modeling has been done. So that's complete. And we are working right now this week. Today, I was even working on this. The hydraulic modeling is in progress. We cannot, oh, sorry, my computer is doing something right now. Just close that. All right, sorry about that. The bank stability modeling is dependent on having results from the hydraulic model, so we have not yet started that. And then Joe asked me to kind of go over the planned deliverables for this project. So we had planned on providing an interim deliverable with the results of the first year of the terrestrial LiDAR monitoring. That's a bit delayed. It's taking more effort than we had anticipated to process that LiDAR data. It's involving a lot of manual, essentially cleaning of the data because of all the vegetation. So we are working on that. We're hoping to have that to you probably before March 2023, but no later than that. We've also submitted a abstract for a conference that's in the St. Louis area for April 2023. We'll provide the extended abstract. So that'll kind of be sort of a preliminary results from the modeling work, just a couple pages long. And then sort of the main deliverables for the project are a kind of joint model archive data release that'll probably be the same product. We'll publish that through a website called sciencebase.gov, so it will be publicly available. The model archive part of it means that it will include all the files that are needed to run the models, and the data release side of it will include the results from the model runs as well as all of our collected data. And kind of the important thing there is that with this model archive data release product, there's no interpretations included in that, but it is publicly available. The interpretive product will be sort of a standard report that goes through the results and the interpretations. And that's anticipated for March 2024. Okay. So I have a few slides here that go through the components of the study in a bit more detail with some preliminary results where we have them. So starting in on the monitoring side of things, with the terrestrial LiDAR, again, our goal is to get 2 scans per year in 2022 and 2023. These pink areas are showing the reaches that are being surveyed with the terrestrial LiDAR. I apologize, this figure still has this one included, but we weren't able to get permission to be in that area, so it's not going to be part of the study. So in 2022, we got out in mid and late February, early March to get our survey, our first set of surveys. And then in mid-July, we got most of the sites done. Unfortunately, that was before that big flood event that happened in August. Ideally, that would have been after, but unfortunately, it's hard to predict these things. We did get one of the sites after that big flood event, so that will be really interesting to see the data for that, see the effects of that big flood. So that was at the Triple Meander Bend site. And hopefully we'll be able to see some of the effects of that big flood as well as in our survey that we collect this February. So I have a couple examples here to show you kind of what that data looked like. So this is an example showing the point cloud generated from the terrestrial LiDAR scanner. So these pink arrows are kind of showing on this figure the view. It's as if you were sort of standing over here looking down on the bank. And that's the eroding bank there. So it's a 3-dimensional point cloud. It's not just a flat image. So these are real points in 3D space that have real world coordinates assigned to them so that they can be compared from survey to survey. And they even have an RGB color because a camera is taking pictures simultaneous to the data collection. And then I'm going to show another example from a different area where we've actually done some of the change detection calculations. So this is from TL4. The eroding bank is here on the left side of the channel where there's your eye keyed into what we're looking at on the next slide. And so in this image,
I think we lost your screen share.
Oh, shoot. Okay. Hold on just a moment. Not sure what happened there. Is it back?
Looks like it's coming back. Let's give it a second here.
Let me know when you see it. It's showing as sharing on my end.
Yeah, it says you've started sharing, but I don't think you guys, yeah, we're not seeing that one.
Let me stop and try again. How's that?
It's still saying the same thing. That's okay. Maybe you can describe the lovely slides to us.
Sure. Yeah, I don't want to delay your meeting too much here. So,
Mr. Chair, if I could offer a solution, if Dr. Leroy could send me the presentation, I could project it for.
Oh yeah, that'll work. So you want to email it to you, Travis?
Who's me?
Sorry, you can't see me. This is Travis Newberry with the Department of Planning.
Yes,
Thanks.
I will do that right now.
That's all right. We'll get it up here in just a second.
Okay, yeah, I'd really like to show that slide because it's kind of fun to see some of the results.
Yeah.
In the
I'd love to see
meantime, I
that.
guess while we wait, I did just fire off that email. But if there are any questions on what I've shown so far, I'd be happy to answer them.
I think maybe the only question I've got is, I'm not sure how much thought you guys had put into what you might find, but if you did, are we kind of in line with that, or are we in good shape or in bad shape compared to where you were thinking we were going to be?
Sure. In terms of actual erosion rates, we've just got that one site that I'm about to show done. So, we didn't go in with any clear expectations about particular erosion rates. Those things are really system specific. And so coming up with a prediction ahead of time, there's not a whole lot of value to that. As far as the modeling results, they're generally tracking with our expectations, with climate change, seeing more intense flows, higher peaks. And with some of the runs we did looking at added storage, that is having the opposite effect. So that's going to attenuate the peaks from the floods. So that's all tracking as expected. We're in the process of calibrating our hydraulic model right now. We're actually calibrating it to that big flood event that happened in early August. And so, that's looking good. We've identified a few places where a little more topographic survey data would be helpful. So that we're going to collect that when we're out in February again. But yeah, nothing tremendously surprising.
Right. Anybody have any other questions while Travis is getting this thing pulled up?
I would like to ask the infamous triple meander. I was wondering how those, I guess I'd call them peninsulas, are holding up. The fear is that one of them I thought was mentioned earlier, that if it's close to collapsing, and that it would be quite a serious situation there. And I'm speaking, of course, behind the Elegant Child area. That's all I would ask.
Yeah, I don't have a good answer for you about that right now. I am glad that that's the one site that we did get after that big flood in August. So, yeah, when we'll be able to answer that question when we provide the interim deliverable on the erosion monitoring. Oh, looks like we've got the slides again. All right, you can advance to the next slide, please. Okay, so in this view, we're kind of standing on the inside, on the not eroding bank, and looking towards the eroding bank. Everywhere that you see blue is representing places where, when we did the difference between the two surveys, there was erosion more than 50 centimeters, or more than a half meter. Everywhere where you see red, there's erosion, not erosion, there's deposition more than a half meter. So the green is any change that's less than 50 centimeters. So that doesn't mean there's no change. It's just that we've created a very conservative threshold for this first look at the data. With looking at some of the uncertainty associated with the data, I think we'll be able to use a less restrictive threshold of 10 centimeters of change in our final product. But for this initial look, we decided to just be really conservative. So there's a couple things to point out to you here. On the right side of the screen, you see a lot of red. That's actually likely due to the fact that in our summer survey, there was a lot of vegetation there. So the LiDAR is just not able to penetrate through to actually return off the bank. But there are a couple of interesting features of real change that we're seeing here. There is a tree that had collapsed into the channel. Thank you. So that little hand is showing where the tree is. And so there is deposition occurring downstream of the fallen tree on the channel bed. And then you can see there are kind of patchy areas of erosion along the bank. And this is based on what we see visually in the field. This is because the bank is tending to fail in kind of blocks, in chunks. And so those areas that are pointed to with the arrows, the amount of change we're seeing there ranges from about 60 centimeters to 85-ish centimeters. So if you could go to the next slide, please. Great, thank you. So these are photographs that I took when we were out collecting the data. And so you can see that tree. So there's actually a little bit of scour immediately behind it, but then there's sediment that's starting to pile up around it as well. And then the photograph on the bottom left is showing those blocks of bank material that are sort of failing as large chunks. And so what I think we're seeing at this site in particular, and probably more generally across the channel based just visually on what I've seen in the field, is there's probably a cycle in which these blocks of bank material collapse or fail. Then that material is removed by subsequent high flows, which can remove that material as well as potentially undercut the banks a little bit, which would promote failure as the cycle. So sort of a cycle of that sort of failure, removal, undercutting. But I also want to mention, and this is something I talked about with Joe and some of the folks at the city, is that it's not just the river processes that are contributing to this bank erosion. As you might guess, you don't actually need water in the channel for a bank this steep to fail. There are sort of geotechnical processes at work here. So cycles of wetting and drying, cycles of freezing and thawing can all contribute to collapsing and failure of these banks, especially in places like this where there isn't a lot of vegetation with deep roots. So yes, there's grass, but the roots of the grass don't go very deep. They don't provide a lot of tensile strength. When you have large woody vegetation like those trees, not only do those roots go deeper and provide some strength to the bank material, when the water's actually flowing, those roots can produce drag and actually reduce the erosive forces of the water on the bank as well. So there's kind of a whole bunch of different processes at work here, but they all sort of contribute to what I'm thinking is happening is this cycle of bank failure and then subsequent removal of that material and undercutting. Okay, you can go to the next slide. Okay, so that was a bit of a preview of our terrestrial LiDAR data. We also installed 14 erosion pins, which are just long 2-foot pieces of rebar inserted perpendicular into the bank. So these are a supplement to our terrestrial LiDAR scans. There are a couple that we located within the LiDAR scan areas, just kind of as a point of comparison, but most are located out of the LiDAR scans because we wanted to get an idea of what's going on outside of those kind of known problem areas. So you can go to the next slide. So we've revisited those erosion pins, and basically what we do with these is when you first put them in, you put them into the bank so that there's just a tiny little tip sticking out, and you measure how much is sticking out. You go back and you measure how much is sticking out later on, and if it is sticking out more, you know some erosion has occurred, or maybe it gets buried, covered by a slump block or something like that. And so that would indicate deposition. So we've remeasured these 3 times since we initially put them in February of 2022. The values on this, they're a little small. If you can see them, they're in centimeters per month. That's kind of assumed to be, that's calculated over that whole period between each time we remeasure it, although that could happen all in one big chunk. It doesn't mean that it's occurring at a sort of slow pace of the same erosion or deposition rate. So the red dots are places where we see erosion, and they've got positive values, which we should probably change that around. And then the green dots are where we've seen deposition. So I think the first thing I'd notice from this is that a lot of these numbers are really, really small. So there are places within this channel where there's not a whole lot of change occurring. Where we start to see some bigger numbers are the places where we installed the erosion pins in our terrestrial LiDAR survey areas, which are our known problem areas. So that makes sense. That's a good sanity check that the places where we're expecting greater erosion is where we're seeing greater erosion. So in particular, if you look at the third panel, the furthest to the right, that is a comparison between July of 2022 and October of 2022. So that includes that big flood in early August. And in 2 of our terrestrial LiDAR areas, I've got arrows pointing to those, we're seeing erosion rates of a few centimeters per month. But again, that's probably not occurring 6 centimeters a month for all those months between the measurements. Most of that probably occurred during or immediately after that big flood event. Okay, you can go to the next slide, please. Okay, so again, I don't want to take too much of your time, so I'll get through this kind of quick. With our hydrologic modeling work, we've completed that. And so this involved a whole bunch of different scenarios, looking at different design storms with different duration and intensity. So just as an example, a 6-hour 2-year storm is going to have the same amount of total rainfall as a 24-hour 2-year storm. But the 24-hour 2-year storm, that rain falls over a longer period of time, so it's less intense over a longer period of time. Whereas in the 6-hour storm, all that water falls within the 6 hours, so it's more intense over a shorter period of time. We expect to see higher flood peaks from that. We looked at scenarios with both normal and wet soil moisture conditions, so we expect when there's already wet soil that we're going to get more of that rainfall ending up in the river. When the soil's dry, it acts like a sponge and absorbs some of that rainfall. And then we looked at both existing climate and future climate. So like I said, this work is complete. We are able to make some refinements based on what we see in the hydraulic model. But for the most part, this work is complete. So you can go to the next slide. I just wanted to show a couple results from our hydrologic model. So if we just focus in on the top plot, this is showing the peak flow in the stream at our USGS gauge for a few different design storms for current and future climate. In this case, we're looking just at normal soil moisture conditions. So the blue bars are showing current climate, and then the yellow, light blue, orange, and gray are all different future climate scenarios. So the yellow and the light blue are looking at predictions for 2050, and the orange and gray are looking at predictions for 2099. That RCP 4.5 and 8.5, those refer to different scenarios used by the IPCC for greenhouse gas concentration. And all you really need to know about this is that 4.5 is kind of a middle of the road scenario, and 8.5 is a worst case scenario. And really the takeaway message here, you don't need to key in too much detail to the actual numbers here, but basically with the future climate, we're looking at higher peaks for the same duration and design storm. So we see higher peaks in 2099 than we do in 2050, so it continues getting worse. And then we also see higher peaks for the sort of worst case greenhouse gas emission scenario compared to the more intermediate scenario. And I just put that black horizontal line on there is showing, just for context, the peak stream flow from the August 4th, 2022 flood, because I figured that might be in your heads as, so that's just a point of reference. So that's about the 2-year or the 50% exceedance probability. That 0.5 exceedance probability, that says there's a 50% chance this storm will occur in any given year. All right, can move on. And then the hydraulic modeling is in progress. We're currently calibrating to high flow events, both from that August flood as well as a high flow in July from this past year. I identified a need for some additional data, and so we're going to grab that when we're out surveying in February. Okay, you can go to the next. Right, and so we've selected our sites for doing the bank stability modeling. We've collected sediment samples there. They're in the queue at our sediment lab to get processed for the grain size distribution. And we're just sort of in a holding pattern on this part of the project until we get those results back and finish the hydraulic modeling. And I think that's it for what I had planned to talk about. So I'm happy to answer any questions. And thank you for your time today.
Thank you. That was really great stuff. Does anybody have any questions? No? All right. So I just have a quick one. I assume we're continuing to take data for a little bit longer, right? Or are we just in the modeling phase now?
So we'll do one more year of the terrestrial LiDAR surveys. So we're going out, our plan is to go out the week of February 27th, weather pending. And then we'll go out again towards the end of the summer to get the sort of after flow condition survey.
Awesome. All right. Well, if nobody has any other questions, I guess thank you so much for keeping us updated. We'll look forward to some more info.
Great. Thank you for your time.
Yeah, absolutely. Okay. Mr. Vunich.
Thank you again, Mr. Chair. The next item on the agenda is a presentation discussion by two of the consultants the city has had participating in this project almost from its inception, that being Joe Wilson and Todd Wagner. As you know, the task force gave them the authority to proceed forward and look at potential retrofits of certain detention retention basins in the upper reaches of the Cox Creek watershed. Surprisingly, and in a good way, the draft report was made available. So we did provide that to you without any ability to kind of talk about it amongst ourselves. But Ms. Holthouse, one of the co-chairs, did have some questions. I provided those to Mr. Wagner and Mr. Wilson. And I think they are prepared to kind of give us some idea of what they've been doing and what they're thinking. So thank you.
All right, gentlemen, let's.
Okay, now I'm unmuted. I'm going to
Perfect.
go ahead and start, Mr. Vunich. That's all right.
Certainly, sir.
Joe and I have both worked on this, but I did the bulk of the report, so I'll step up and go ahead and I think you've had a chance to look at this, and it's not a terribly technical report. So I'm just going to very briefly discuss this, and I know we've got some questions here in front of us that we can try to address those and address any other questions that you have. But just very briefly, this report I really put together more as looking at the options, the different basin options that we were given earlier, the ones that we thought probably had the most potential, which were basically the out of the 100 and some basins we originally looked at last year, these were the ones that were the largest and seemed to have the most potential for reducing flow, so that we could have some benefit, show some kind of benefit in reducing flows to Cox Creek to the main channel and try to reduce the speed at which erosion is taking place. And Jess is documenting that, and I can attest to being out there several times over the last couple of years that it does continue to erode pretty rapidly. So time is, I'm sure you all are realize that time is of the essence to address those problems. So we looked at, actually ended up looking at 8 total basins. And if you look at table 1, there's a listing of those, the ones that we thought had the most potential. Following that, page 4, page 5, then you go into what's really, I would call a series of worksheets where I put together some basic parameters that would give us a sense of which one of these basins would have the most potential for improvement. And so one line of thinking is you're looking at opportunity and you're looking at risk, okay? And so you can think of it as each one of these basins has their own set of opportunities and risks associated with modifying them in a way that we can manipulate their discharge into the creek in such a way that we think it'll benefit the creek, provide benefits to the creek. And so when we look at opportunity, ironically, you kind of look at which basins are least effective in their current state, because if they're least effective, then they're actually going to have possibly the most room for improvement. If a basin is doing a really great job, a lot of your newer basins designed to the newer criteria may already be doing a good job of controlling flow rates in such a way that they protect the channel of Cox Creek. So let's find some basins out there that aren't doing a very good job. And so when you look at them and you pick off certain parameters, you can tell this was probably a basin that was designed many years ago under old criteria. How much volume is there in relation to the size of the watershed? And these things, and how is the outlet structure designed, or how does it function? So these kind of give you indicators of what kind of opportunities you have to make it better, make it more effective. Then on the other hand, you have risks. And so if you look at a basin that doesn't have a clear overflow spillway, if the outlet structure were to get blocked and it didn't carry water for a while during a flood, if the water surface keeps going up, will it flood some homes before it spills over a road, for instance? If you're looking at the Copper Lakes area, those 2 ponds, for instance, there's an outlet structure, there's a concrete outlet structure, but there is no spillway above that. So if those were to get blocked, or if you had that 12-inch rain again that you had last July there to your, or at least close to you, it occurred in St. Peter's. If you had that in that watershed, you know, that's going to flood some homes likely before it's going to spill over the road because of the elevation of the homes in relation to the road. So those are risks that you look at. How much, what we call freeboard, how much space is it from the water surface up to the first thing that would have flood damage? So we're looking at freeboard that's available. You look at what the banks look like. In other words, water moves up and down during a rain event. Could you potentially cause erosion? So do you need to provide some riprap around the edge of the lake, for instance? So we were looking at opportunities and risks. And so that is what you see there on those worksheets, is a data set for each pond that basically gives us enough data that we can, I'm gonna call it just really making an engineering judgment. And Joe and I actually looked at some of these basins kind of independently, and fortunately, it was encouraging to talk to him, and he was kind of prioritizing these basins in a similar way that I was. So we were looking at these and making our guess you'd say, our judgment that old hydrologists make that have been around a while. We were coming to kind of the same conclusions on which ones looked good and which ones didn't. If you would like, I'd like to address at least a couple of the questions and comments that was brought up. just to clarify, what I want to point out is in table 1, the column, let's see, we have a column there that's volume, and there we go. Thank you. Perfect. There's a volume. There's a column that says volume. Okay, so to the right of that, column is this other column that probably is confusing without an explanation of what that is. So what that is a ratio of the volume that we measured in the watershed. I'm sorry, in the basin. That's a ratio of the detention area's volume divided by the amount of impervious area that's in the watershed. So it's basically the column to the left of it divided by the column two columns over to the left. And so what that is an indicator of how much volume is there per amount of area of the watershed. And so if it's a pond that has a lot of volume compared to the amount of water coming to it, then that number's big. If you're looking at the third one down there, that's the upper pond in Lake Chesterfield. You see that's very small. The reason is because there's 366,000 cubic feet available, which sounds like a good number, but the watershed is so much larger there than the others. It's estimated 83 acres of impervious area draining to that. So that ratio of volume to impervious area is very small there. And so what that tells us is it's just an indicator of how effective is that detention currently. And so that would tell me that probably the Lake Chesterfield upper pond is probably not doing a whole lot to reduce flow rates. It's mostly a pass-through pond, what I would call a pond that just goes in and it goes out fairly quickly without storing a whole lot. So you're not really reducing flows very much. So that tells me you might have a real opportunity there. And so that's just an indicator of opportunity, I guess you would say. And it's not necessarily something, I believe there was a table put together to show that was kind of a bang for your buck indicator, and it really isn't. That's not what that number really means. So I want you to be clear that was what that number was being used for, and I wouldn't use that for trying to determine which project would give you the most benefit for the cost. So there was, go ahead.
Is there, I guess in my simple head, I sort of said, well, you've got, a detention basin that's holding so much water now with its current design, and with modifications would hold more or slow the rate. And so is there anything here that sort of shows me that what we would get in terms of a different volume into the creek from any particular basin?
Yeah, I understand what you're getting at, and that makes sense. You'd like to be able to see how much benefit could I get in volume. The difficulty in determining what that is just not having enough survey information around the edge of the ponds to know exactly where those homes are sitting or how much easement you have available. So it's hard to know really exactly how much volume you could really get, because at this point, we're not sure how much we could really raise the water surface without getting more detailed information. So we would probably have to get into that if the next phase, we would get survey information in the next phase, and we could really start nailing that down. So unfortunately, I don't have that clear of a marker of when you're looking at benefit cost, we don't really have that in so much as in a specific number. We just have some kind of general indicators that say, yeah, West Glen, for instance, the top one there, appears to have a lot more freeboard there above the water surface. So that was one reason why Joe and I both really liked that top one, because it appears to have a lot of opportunity without too much risk of potentially flooding adjacent properties. Now, we haven't looked at easements and things of that nature, so there are still some unknowns out there. But it had what we thought was a lot of opportunity with less risk than most of the others. The number on the right column that you'd asked about, that's not determined by math. That was really determined by looking at all these parameters and saying, I really like this one because I see a lot of potential and not as much risk, or maybe there's some risks, but there are enough potentials to still make it look good. And you're exactly right. The 5 was a threshold. When I tried to come up with numbers that reflected how we felt about these different possible retrofits, I just basically tried to put them in an order that reflected which ones we saw as having the best opportunities and the least opportunity. Those 3 that are in white, that are below 5, there's just not enough drainage area there, or there's too much risk for the amount of benefits you would get. So I agree with you. I would not pursue those any further. The other 4, you could consider the bottom 2 one. They're both at Copper Lakes, but either 4 or 5, however you want to look at that. 4 or 5 others, I would suggest you consider those being looked at further at some point. They would be worth pursuing. They may not pan out for some reason. They may just not be able to get enough benefit for the cost when you really look at it closer. But from what we can see right now, I think those are the ones that give you the best bet for some kind of positive result that they would work. So that's really what I have. I didn't really want to talk a whole lot about this. There was a question about, did we consider cost? That number on the right, in the right column, would be what I think how we felt these projects looked just purely from an engineering standpoint, and didn't really look at it from a benefit cost ratio type of standpoint. So, you'd have to kind of look at that and compare it to the next table there to kind of come to those conclusions. But also, I just want to say these costs are, they're very preliminary, and that's why I threw out the last 2 columns there in a pretty wide range, because I tried to estimate high. Some of these could be much lower if it just ended up being some modifications to the outlet structure, for instance. And they could possibly be quite a bit lower than this, but I just tried to account for all the potential costs that you might run into there. And so if anything, engineers don't want to estimate way low. We would rather be on the high safe side. And then when actual numbers come in, if they're lower, then, we look a lot better that way, I guess you'd say. Or you all are a lot happier if you can get it in prices that are going to be less than that. So those are very rough, and I just call those a concept level cost opinion. Those are very conceptual, and I would really hope that at least some of those could come in underneath the numbers that you're seeing there. But we'll just have to get into further analysis before we'll really be able to give you some good solid estimates.
Right. Carol, I see you got your hand up.
There was one of the basins, I believe it was number 1, where you mentioned there was a possibility of needing probably a probability of needing some sort of spillway. It wasn't clear to me whether it was during construction or is that kind of built into that high range cost, or would that be something that would push that one higher than the range on the others?
Yeah, on West Glen it's just a simple concrete structure. Probably the way it looks now, it's probably fine. It does have a sag point in the berm that is probably 30 or 40 feet long that drops down a foot or 18 inches or so. I shot some elevations on it. So it is low enough that I think the berm would need some repair work on it, excuse me, to get it level. And then if we could get a lot of benefit out of that basin the way I think we could, we might end up raising the water surface enough during flood events that you might have to add some emergency spillway capacity there. I wouldn't see that as being a huge cost, though. In the grand scheme of things, there's 56,000 budgeted there for construction, but that did factor in some cost for that, and I really wouldn't expect that it would have to be a huge expense.
All right.
And like you're talking
Anybody have any
emergency
other?
spillway, and
Yeah,
when you
go-
talk
go
about,
ahead.
you say the word emergency spillway, you might think of this massive concrete structure with a big flume or something. And I mean, this is emergency spillway for like 100-year event, so it could possibly be just a riprap, a dip in the berm with some riprap in there to allow the water to flow over it and down to the creek without causing erosion. So it could be something, relatively simple and not too expensive to build.
All right. Yep. Carol. You're muted again.
My next question is not so much for the engineers, I guess, as it is for the committee and maybe Joe, being a council member, you can speak better to, what if any of these projects would be feasible, to fund this year or the next 2 years. I mean, if you get down to $50,000, I'd like to think that might be possible. Is it even worth, doing engineering on, $100,000 projects if we don't think we're going to be able to come up with the money to construct them?
Well, I mean, I guess I can maybe speak a little bit to that. Mr. Vunich and I were talking about that before the meeting. We do have money in the budget for this year, right at around 750,000. That was sort of set aside in the event that we were able to get some other funding mechanisms to kick in. So as we kind of evaluate those things, I think that there's a pretty distinct possibility that we could certainly move over some of that money to tackle some of these projects. I mean, I personally think that would be a good thing because, a lot of these things are kind of pretty visible to the public, so they would be able to see that something was actually going on. And they seem, at least to me, to be low enough dollar amounts that we can actually do the project as compared to having to ask a bunch of people to please give us money and also please let us do this thing. So I think there's a good chance that we could do that. And also, I had a trustee meeting last night with my 2 other trustees in West Glen Farm. So we're very open to whatever needs to happen over there at the pond. We, are happy to make that work. Mr. Brown, I see you got your hand up.
Thank you, sir. I was just, and Joe Vunich and I have not talked about this, but I believe Mr. Wagner does have some preliminary costs for engineering in his table there. So certainly, in my opinion, if this task force wanted to move forward with some additional engineering, I'm sure Mr. Wagner would be happy to do that. And we could certainly negotiate that change with him if that's the desire of the task force. And that would give you a better handle on costs, feasibility, need for easements, those sorts of things, so that you'd have a better handle on construction costs and that sort of thing.
Yeah. So just to clarify, Mr. Wagner, I mean, if a handful of these are scoring kind of below that 5 number, and we probably don't want to mess around with them all that much, we could probably knock several of these out, I would think.
Yeah, I wouldn't, I honestly, I couldn't even, honestly feel good about doing a lot of more work on the ones that are in white there, because I really don't think those are going to go anywhere for you in kind of providing any kind of meaningful benefit when it really comes down to it. So yes, I would recommend that if the other 5 there, if you are wanting to look at the ones that you think that would likely come up with some kind of benefit that would be, worthwhile and significant, those are the ones that we think would potentially give you that opportunity.
All right. And then Carol, go ahead.
Could we scroll down to maybe the Deerbergs one, which I think is the pages, the pictures and that sort of thing. For, I think it's basin 4 maybe. So yeah, going down in the report. I don't know who was putting that up on the screen, but
Yeah, I think
Travis.
it's maybe the third from the last.
yeah,
It's down closer to the end.
anyways, while we're going there, I guess it looked like there were 3 detention basins, one of them being the Deerbergs one,
Right.
that we looked at, but there's 3 detention basins that are, part of town, kind of integral to the area that's town center. And if you start looking at the pictures, I mean, they're really, let's just put it, they're not aesthetic assets to the area. They're kind of, ugly pits, weed pits with, fences around them and, chunks of concrete in the corner. And I'm wondering just, your opinion on whether there's any opportunity to do something that might be aesthetically more pleasing, or maybe, enhance some of the amenities of town center if we kind of expanded our thinking a little bit to what could you do with this space besides detain more water. So that's my question. Open-ended.
Yeah, we looked at, or I spent some time looking at all 3 of those. The 2 on the east, now they are, especially that southeast one. It's like you said, it's a long ways from that parking lot down to the bottom of that basin, and it certainly has a lot of trash in it. It's just kind of unsightly, unfortunately. But those 2 basins actually have pretty restrictive controls on the bottom end of those outlet structures. The northeast one is quite a bit smaller volume wise. And they really, like I was saying before, when you look at these, you say, how effective are they? And if they look like they're pretty effective now at reducing flows from that 1 or 2 year storm, which are the ones that we're really interested in when we're talking about downstream channel erosion, then those 2 basins appeared to me to be probably doing a fairly good job. So as far as hydrology goes, as far as stormwater releases go, I didn't see as much potential for improvement on those. Aesthetically, sure, they could probably use some changes. They could be cleaned out. They could have trash cleaned out of them, sediment cleaned out of them, and they would function better. But when we went over and looked at the big one on the southwest part, its controls weren't as restrictive, and it is what it is. It's a big, what I used to call as a stormwater engineer here, is a big bathtub basin. It's 4 vertical walls. And so it is, that's hard to change. So you're kind of limited what you could do aesthetically there, except you could clean out the sediment in the bottom, which it has accumulated a lot. And you could get back some low end storage, is what I would call that, which would help with your flow releases. And you could probably make some restriction on the outlet structure, because it just looks to me like it's probably a very large amount of volume there for the amount of drainage area that it has. So I think you could probably restrict the volume down and reduce the flow discharge to the creek there. And it does drain directly into the creek just to the south there. So that's why I thought that one probably had the most potential as out of the 3. So So yeah, I mean, it's kind of one of those things where you could start kind of trying to think out of the box a little bit on what are some things I could do right here in my backyard to make it look better. So that'd be something that we could certainly think about with you.
And I guess I may be going even one step further of, can it be a fishing pond or have a trail around it or a bridge over it or something like that? If what would it take to maybe put some water in it and
Yeah.
make it a bathtub that was full instead of empty, I guess is the question.
Yeah, well, that's something that could be looked at for sure. And I have to say, it's a really great, really nice area there, nice shopping center right next to your government plaza. And it's unfortunate that they look like they're just not being maintained real well, and they could look better with with a good maintenance plan and some operations there to keep them looking better and keep them functioning better too. They're losing some function by the fact that they're not being maintained real well.
Mr. Sturman.
The additional, what I wanted to ask is the scope of additional engineering that is required and the cost for it that has yet to be done to actually do some work. Is that and what all it takes to prepare construction documents? Is that the scope of additional engineering and costs we're still talking about?
Yeah,
or is there more than that? Or
if we're looking at table 2, I believe, table 2. Those are conceptual, and so I feel the preliminary design is the bulk of that is doing a model similar to what Jess was talking about for the entire Cox Creek. She's done a model for what we would need to do to make sure that whatever we propose is being done safely and responsibly. We would create a small model for the watershed that serves the basin and model those flow rates. And so most of that preliminary design money would be for the modeling and for developing options for what you would actually do. Like I would modify the outlet structure in this way and just basically come up with the idea that you could describe. This is what the project's going to be. And I've run it through the model, and this is the change that you're going to see and the amount of benefit that you're going to get from that, and how the water surfaces will be different and so forth. So you can explain, you can answer those questions to the neighborhood and to, you all and to the planning staff. And so that's what the preliminary design would be, is just defining what a good responsible design would be for each one of these basins. Then the final design would be basically taking that concept and putting it on a drawing and putting it out to bid. So you develop construction bid documents and specifications for you to, and I would anticipate you'd probably want to, maybe if you did several of these, you'd put them all out to a single bid so you'd get better prices from your contractor. And we talked a little bit about that with Mr. Vunich. But you could put together a bid package or 2 or 3 bid packages. And that's what that was geared towards, is what we think probably about what it would cost to put that final design package together. Without knowing what the final design is at this point, that final design column could vary up or down quite a bit. The preliminary design column we feel pretty good about. So it just depends on what your ideas are for what you want to do to the basin to determine what final design is. But again, I tried to err on the higher side so that you're not disappointed in inflationary prices and pricing on this. But and then Joe also mentioned a survey, so I threw in $5,000 for each one to get survey data around the perimeter of the lake.
this might be a dumb question, but when you say model, your term for a model, is that an actual model of the basin, as in a building model?
No, it's
Or
a
what?
computer. It's a computer model.
a computer model, what would that, in just simple terms, what would that computer model indicate?
What you do is it would be a hydrologic model like what Jess described, the hydrologic part, or the first part of those two modeling steps that she had. You would develop a hydrologic model that would basically, you would put the design storms. So we would look at probably everything from a 1-year storm all the way up to a 100-year, or maybe even a 500-year storm event. And you would take that rainfall and you would apply it to a model of your watershed, which is the model defines the size and the soil and the slopes and you know, the urbanization, the level of urbanization in the watershed. And those are the things that affect, when rain falls on the ground, how much of it runs off and how fast does it run off. And so that model uses a series of equations and different things to estimate what that is. So that's what the model is.
So it's hydrological engineering,
Yes,
kind of related to what they do, but then does that take time to have to go out and do gauging like they're doing at all? Or is that just, and some canned computer programs and
it's using a computer program, and it's using just engineering standards. You gather a little bit of data in the field. Some of it you can get off of maps. Some of it you go out in the field and gather, but it's not near the level of data that the USGS is gathering. These are small watersheds. These are 40 to 80 or 100 acre watersheds. She's modeling a massive watershed that she's doing it right. You need to be getting actual data so you can calibrate your model at that scale. But at the small scale we're working at, you wouldn't normally be doing any gauging data. It's all just input based on engineering standards.
But all of that work you've just described, the modeling through the construction documents, the cost for that has to be added to the numbers you just showed us?
No, the preliminary design column would be the hydrologic model primarily, and the concept or the preliminary design. The final design would be production. Those numbers you see there, that's the cost of producing final design documents for bidding purposes.
But the numbers you just showed us, the total project cost. In that total project cost column, which you had a high and a low, does that include all of this engineering work we just discussed?
Yes. What you're looking at there, if you add the 4 columns to the left of total project cost, that should add up to total project cost.
Okay, so that's in there. Okay.
That's your mid range, and then there's a upper and lower range just to bracket it. Yeah.
Okay. All right. Thank you.
Yes, you're welcome.
Mr. Wilson, I see you got your hand up. Did you want to add something?
Yes, sir. Thank you, Co-Chair Farmer. Our approach on these types of projects, the way Todd has laid that out, we run through a preliminary design phase and do the hydrologic modeling and do enough analysis to determine whether that project is viable to continue with final design. So the way we structure those projects is, if we get to a point where we see that, for example, the Deerbergs site, there's just really nothing we're going to be able to do with it to make it any better, then we work with you to determine which direction you want to go from there. Either completely remove it from the project or put those funds to a different project. So we like to do those in phases. Get it to a preliminary design phase. Get a report to you or a summary, so that you can make informed decisions as to whether or not you see a adequate cost benefit going forward.
All right. Carol, I think I saw your hand pop back up. You got something?
Well, I just was kind of looking at the bottom of table 2, where it talks about if we dropped out those, 3 that didn't make the kind of likely to turn out well list, and proceeded with the 5 basins that were green in table 1, we could proceed with that preliminary design for $50,000. And, if everything, there were no big surprises and, a few puts and takes, even the total project cost for those projects would be within the budget that was set aside maybe for some other purposes. But, we have some scope identified that it's within our means to address and move forward. And even if we can't fix the most critical locations, we can prevent them and other locations from getting worse or deteriorating as quickly as they would do if we, sit around and wait for, millions to fix the critical locations. So interested in the temperature of the group of, proceeding kind of on a tack of let's be, doing smaller things that are proactive versus saving our powder for, the critical wounds.
Anybody want to throw any thoughts out to that? I mean, I'm with you, Carol. I think that we're to a point where it would be great to start moving some things around and doing some things. I don't know that we want to probably spend every cent that we've got set aside just in case something comes through. But I think that if we continue to wait on some of these things, we're probably going to wind up pretty disappointed at the end of the day.
I agree.
Sure.
It sure would be good for us to have some work actually happen. I think that would, I don't know about others, but I don't know. I think that just would be a good boost to all of our efforts of this task force. Some people can see some action going on.
Yeah. Mr. Miller.
Yeah, I just have I'm trying to make a connection again between the detention ponds and the triple meander, okay, which of course was high on the list at the beginning of everything. And I'm still unclear about dealing with the detention ponds and what the actual effect will be on the triple meander, so that, we have the USGA going on that's saying it's eroding and that kind of thing. But I'm trying to make a connection between the value of retrofitting some of these ponds and whether or not there's going to be an immediate effect upon literally slowing what happens at the triple meander. Can you help me with that, Mr. Wagner?
Yeah, that's a good question. Just get back to the basics of why we're doing this, right? I think I'll try to explain what I think you get and can expect versus what you can't expect. I think going back to when we were looking at this a year or two ago in our first report, and we said, you've got a large watershed here, and you've got several large basins for a few hundred acres of that overall larger watershed. We think we could reduce flows from these areas by retrofitting these detention basins. So you have to keep in mind there's a big urbanized watershed out there, and what we're trying to do is retrofit pieces of it and small percentage pieces. This is only a smaller percentage of the overall watershed. So what you see is, I think what you would expect to see is that you get small incremental improvements in flow in the Cox Creek main channel. You're going to see small incremental improvements each time you do one of these that reduces flow that's going into the creek. That's not just at the triple bend. It would be everything below where these basins are located, all of those stream channels, and there's a lot of other locations, as you can see on the USGS study, where you've got a lot of erosion occurring all up and down. So anything that's downstream of this, you're going to see some small incremental improvements each time you do something to reduce and try to get your runoff more like pre-development conditions, more less urbanized, I guess you would say. And so trying to turn the clock back. So what you're doing is you're changing the status quo, so to speak. You're saying, okay, from this point going forward, I'm going to see a little bit of change. Even I know that Triple Bend, Meander, and the others are active erosive processes that are in play. They've been going on for many years, and they are still actively eroding. And like she said, water washing up against that bank is not the only reason those banks are failing. There's geologic failure going on there also. Just even if there was no water in that bank, it's going to slough off. It's going to continue to do that to some degree. So these are processes that don't just reverse immediately. What you try to do is you try to begin to slow them down. And I think that's what you're doing here, is you're trying to slow it down, do something to stop the bleeding, I guess you would say, or at least begin to slow down.
So do you think that there is enough volume adjustment for us to see what I would call kind of a significant change? I know you keep using the word incremental, but in terms of volume, the water that's going to flow, there's going to be less. But in your opinion, is that flow going to be significant enough for us to say we've made a difference? And I know that's based upon how much does it rain and how big is the flow.
Yeah.
I understand.
Yeah. There's so many variables, and you could get a big flood and see 5 years from now and still see a lot of damage done on the channel. So there are lots of variables in play there. So this is one variable that will make an improvement over time. I would say, just doing 1 or 2 or 3 basins is not going to change the world. Hopefully this is something that you do in the future and you take a lot of different measures to try to reduce the flows and to try to do some repairs on the creeks. All of those things add up. It's a variety of different things that you try to do to bring those creeks back to more like pre-development conditions. So it's just hard to say, yes, this will definitely, you'll see a big difference in the next 3 to 5 years or whatever. I think over time, as compared to what would happen otherwise, I think this would be a better scenario for you than doing nothing at all. But you're likely going to continue to see erosion on those channels, just hopefully not as severe as if you're just doing nothing, but just continuing on.
Okay, thank you. Appreciate it.
One question I guess I have, we can just use the Westland Farms one because that's the one I'm most familiar with. So I think that pond has been there for like close to at least 40 years, functioning the way that it currently does. And I don't think it's ever been, I don't know if it's like dredged or whatever has run into that thing for 40 years is in it. So as part of the engineering of this, is it just working on the banks, or is it like adding volume by digging out some of the stuff that is in there? What is it? What do you kind of envision that looking like?
Well, when you're talking, Joe and I were just talking about this the other day. Yeah, anything below the current water surface that you change, that doesn't give you any benefits as far as flood control goes. It might help with the quality of maybe the itself, such as algae blooms and things. Sometimes it's good to clean out ponds periodically to get the sediment out of the bottom because they contribute to low water quality. They can. But so that was something that I had thought about. When you start looking at these closer, we may see some issues like that pop up. Like, hey, you know, this pond is only 4 feet deep now. It used to be 8 feet deep. So that's an issue. It's not really why we're doing this project. Cleaning out the pond isn't going to change the way that it stores floodwater, because that's always there. That's a different issue, but it might be something that comes up and that we would make you as a property owners association aware of. But yeah, this would involve, I would anticipate what this would involve is modifying the outlet structures that control the water surface, the permanent water surface and the water surface during this flood event, and possibly some work on the banks to try to protect them from having and developing erosion problems that you possibly didn't have before. We wouldn't want those to develop after the project was done because of what we did. So we'll that's primarily what we'll be looking at, I think.
Yeah, Mr. Vunich.
Mr. Wagner, this is Joe Vunich. So use the example of you have a glass that has a small ball in the bottom of it and you start to fill it with water. The ball is going to reduce the volume of the glass so that you cannot put as much water in it. I'm under the assumption that if there was a design standard for these basins, whether detention or retention, and they're silted in, we can increase the volume of the basin by removing the siltation or the material that's in the bottom. So in principle, I would think that would be a positive.
If a basin was empty, like in your example, you started out with an empty glass, such as the basin, what we call it there by City Hall, that big detention basin that's dry. Cleaning out silt out of that basin would give you some benefit, just like taking the golf ball out of the glass, empty glass would allow more water to go in. But if the glass is already full over the top of the golf ball, it doesn't hold any more water. When you go to fill that glass up, it doesn't change anything. So that now it does from flood control. Now from a water quality standpoint, because there's a thing called residence time, when water flows into a pond, how long does it stay in that pond before it flows out the other end? From a water quality standpoint, as far as reducing things like sediment and nutrients, cleaning out your pond is a big benefit. It can be a big benefit. It can help in reducing algae blooms in the summer because you've got more volume and less nutrients because you've pulled that out of the bottom of the pond. I'm not saying you should never clean a pond out. For water quality purposes, yes, it's good. For flood control purposes, though, for reducing that 2-year flood, like what we're talking about, to try to protect downstream channels, cleaning sediment out of a pond, out of a wet pond, that's really not going to do you any benefit.
May I again, with your permission, but if the pond had a depth that was established at the time of its construction, and that depth has been impacted by siltation that's been brought in by stormwater, don't we want to restore the design criteria that was originally intended for the pond?
That would be a good idea. Yes. It's the reason. What I'm saying though is that that does give you some benefits to put that resident storage back in place, that underneath the water surface storage. That's something that should be done on any wet pond periodically, is to restore that to its original design volume. But it's very expensive, and the benefits you get are from a water quality standpoint, the quality of the water in the pond, the aesthetic value of that pond, and possibly things like the amount of sediment and nutrients that are attached to that sediment going downstream and also causing algae blooms downstream. Those are the things that are related to removing that silt and sediment from the bottom of a pond rather than reducing the actual flow rates that are coming out of the pond.
Thank you.
Mr. Sturman.
Mr. Wagner, it would seem to me, I'm no expert on detention ponds, but it would seem to me to be quite normal with Mr. Vunich has talked about the silt on the bottom of these, or you two. That to me, like 40 years there near West Glen, that would seem to me to be a very obvious common situation that occurs in these ponds with much age at all. And that it would make nothing but common sense, you know, to, as you agreed with, to clear them out. And, you know, that's being the case, again, back to cost, would that increase your pre-construction estimates?
If you were wanting to do that, say on West Glen, you were wanting to drain the pond and go in, you'd have to let it dry out, the mud dry out, and probably go in with excavators and remove that material and then find a place to take it. And then compact it when you're done to make sure you have it nice and tight when you're done. You don't want to leak. So that's a process that you know, I went through as stormwater engineer at the city. We went through that occasionally, and it is a process that takes a while because of the drying out of the mud to get it out, and it's fairly expensive. So you would definitely increase the cost of, you know, what I have there, about $100,000. You could easily double that if you decided you were going to do a full pond clean out. So just something to be aware of.
Well, as a rule, when you do these sort of projects, do you or do you not, as a rule, clean out silt, or do you leave it?
You would not need the kind of project that we're talking about, have been talking about here. You probably would not drain the pond. You would do it with the pond remaining wet. If you're going to clean out the silt, you can dredge the silt and not drain the pond. You could do it like they dredge the Mississippi River, but that's the experience that I had in the past. That's more expensive than just draining the pond and just simply using excavators to excavate the silt out. But that's something that, you know, if you're interested in doing that, that's certainly something we could do some investigation into that to see what that would actually cost.
So then what you guys are kind of proposing, just to keep it as simple as I can for some of the people in the neighborhood or whatever. So the spillway that is there currently, that like cement thing, obviously when the water gets to a certain level, it starts to spill down into the creek. So the general idea would be to move that up basically so that there's more water remaining and then it drains slower.
The openings would be made smaller in some way so that any given rainfall event would pond higher, and you would get more storage and you would release it at a slower rate. That's very general, but that's basically the idea. Yeah.
All right.
You could change the permanent pool either up or down. That might be part of the plan, but that would have to be looked at for each pond individually.
All right. Does anybody have any other questions? Carol.
I guess I've heard, you know, conversations tonight about, you know, two things that might potentially help our issues be preventive. You know, one is working on detention basins. The other thing that was mentioned in the earlier report is just what a difference trees might make on the bank. So, you know, I know it's kind of a weird kind of thing to maybe put you on the spot on, but you know, how many acres of trees would we have to plant to, you know, equal one detention basin? Or, you know, if you have to kind of look at those two alternatives or think about balancing them in your experience. I know it's a off the wall question, but if you can speak to it, I'd appreciate it.
Yeah. If I was just going to step back from all the work that we've done for you all, you know, up to now with a lot of engineering and looking at channels and basins, but One thing that I pulled away from my experience with the city of Springfield was that one of the most basic and beneficial thing you can do any community is to protect the riparian corridors along your creeks. And actually, I've told Mr. Vunich just before, you all have planned this community really well. And you do see most of your corridors protected, and even a lot of them even have trees, and some of those trees are falling in the creek because there's just so much erosion going on these channels. Nevertheless, I would say any place up and down the channels that you can establish tree riparian corridors or reestablish them, that would be something that I would think as a community, that would be one of your strategies to improve Cox Creek, Bonham Creek, whatever. And so, yeah, I would encourage you to look into opportunities to obtain, plant a lot of trees in those areas. Some of the areas that she showed you earlier in the evening, they were starkly bare of trees, right? And and then you see other areas that, for the most part, when you have trees, it is more stable. But where you do not have trees up against the channel, you're almost guaranteed you're going to have a lot of erosion. So reforesting those areas, I think, would be one of the things on your menu of things how you're attacking this problem. Stabilization projects should be on the menu. Retrofitting your watershed in various ways should be on the menu, and reestablishing riparian corridors should be on that menu too. So that would be my big broad brush advice for good watershed management, and all of those things together. You just chip away a little bit more at the problem and try to restore it back to a more pristine condition. I hope that helps. To be able to compare a retrofit to so many trees, that's a kind of a hard thing to do, but they're all good practices that I would advise you to look into and try to do as much as you can.
All right, Ms. Donaldson.
Are there any particular trees that you would recommend that have a better root system? Better? Or does it not matter?
I think it does, but to be honest, I'm not the expert at the tree species level to be able to really give you good advice on that. But I would say usually the best is to look at what you have growing natively in the area and try to match your natives. And that's probably your most likely success rate right there.
Thank you.
All right. Anybody have anything else? All right. Yeah, gentlemen, thank you so much. Unless you had anything last thoughts you wanted to add on, I think we're good. Thank you so much for the presentation.
You're welcome. Thank you.
Thank you.
All right. We will talk again soon, I'm sure. All right. Let's see. We've got an update on our projects. Is that right?
So, Mr. Chair, I
Funding, I
have
suppose.
one item before that.
Yeah, please.
And we've kind of bled into it as part of the discussion with Mr. Wilson and Mr. Wagner. But there is an opportunity to fund certain activities of the Watershed Erosion Task Force if the $750,000 remains available. And so what the department intended to do tonight is to again identify those, so to speak, 6 priority projects and the project cost estimates that Mr. Wagner and Mr. Wilson provided back in 2021, as well as to identify again the retrofitting of the basins, whether detention or retention, and the original estimate that was provided by Mr. Wilson and Mr. Wagner, which was in the range of $200,000 to $300,000. As we see tonight as part of the preliminary draft report, that number is kind of escalated to somewhere over $300,000 up to about $500,000. So what the department is proposing is that we kind of look at what approach we do want to take. And I think Co-Chair Holthouse kind of started that by saying he wanted to kind of test the waters, no pun intended, to see what direction we would like to go. I think also now, after our most recent discussion, we obviously ought to look at a tree planting program. Those are certainly well received by property owners as well as trustees of homeowners associations. So certainly we could add that to the list. But for now, we have projects that have been identified with certain cost estimates. We have a preliminary report that identifies at least 2, if not up to 5 basins for potential retrofits. And then finally, a tree planting program. So at the time now, it's probably, unless the co-chairs disagree, not the best time probably to enter into a lengthy discussion about what projects, what basins, et cetera. But I think that would be the item of discussion at our next meeting in 2 months.
Yeah, I mean, I think that wouldn't be a bad idea. I almost wonder if, I mean, I don't know what additional level of flexibility we need, but maybe we can even send something to the council to talk about, you know, hey, we've got some new information on some detention basins and some things that we think we can really get an impact on. And, you know, just to give them a heads up that we're starting to kind of move in that direction as compared to just waiting for some of these other dominoes to fall, so to speak.
No, certainly if it's the desire of the task force, the departments, that being Public Works and Planning, can have something at the next council meeting on February 13th.
Because I'm just going to pull this up here. I mean, if we're talking about, tell me if you think this is maybe too crazy, Joe. If we're talking about these top, just with the detention basins, if we went with their recommendation of these top 5, and we were talking about just doing the preliminary design work for those, I mean, that's like $50,000 or something. So I would feel pretty comfortable gambling with $50,000 that some of these things aren't all going to pay off the way we think they are in terms of getting money in. And so we can maybe get that engineering going as we've worked to do so far to kind of keep us ready to go. Does that make sense?
Certainly. Again, the total cost of the project is one thing, but as Mr. Brown noted, if we're truly serious about proceeding forward with the retrofits, we've got a lot of pre-steps, which is inclusive of the preliminary engineering. So if the task force would like to make a motion tonight to proceed forward and obtain a proposal from Joe Wilson and Todd Wagner for that preliminary engineering, and if it's within that range of $50,000 to take it to council for action, we can certainly do that.
All right. Rick, this might be a you thing. I know this isn't exactly your expertise, but what kind of a timeline do you think that preliminary engineering would take?
That's a good question for Mr. Wagner. Really depends on.
I realize I should have asked that before.
I would like to think that's something they could get done in a few months. But I don't know that I want to commit for him, but that should be a matter of months, not obviously a year or more, to get that work done. But I'm sure he could provide an answer pretty quickly, or a schedule for the task force.
Okay. All right. Well, is there anybody out there that would be interested in making a motion to start the process on the preliminary engineering on the top? I guess we'll do the top 5 as they suggested. Detention basins. So that would be, let's call it, $60,000. Anybody want to do that?
No move.
Motion.
All right. Well, between Mr. Sturman and Mr. Delonte, we've got a first and a second. Okay. Anybody want to discuss that? Any questions, concerns? All right. Well, let's do something. I'm with it. All right. All those in favor of getting that put together for the next council meeting, please say aye.
Aye.
Aye. Anyone opposed? Anybody abstain? All right, Mr. Vunich, you've got your motion.
Well, just doing the simple math, and I hope I'm correct, we started with $750,000. We've just allocated 60,000 of that amount, so we have $690,000 left. So again, I would like at our next meeting to be able to kind of talk about maybe a project or further detention basins or the tree planting program.
I
Thank
think,
you.
yeah, I think we do all this. Do we need to talk to, I don't know, Davy Resource or somebody that knows a little something about the trees?
Certainly, and I think that's something Mr. Brown, Ms. Ripito, Mr. Newberry, Mr. Ron, and I can do and have prepared for the meeting.
Mr. Berger, I see you got your hand up.
Yeah, thank you. I'm curious if we are able to get aligned on maybe a rubric or some sort of framework for us all to get on a similar footing around understanding, what initiatives we've got on the table, what budget we're looking at spending, and some way, shape, or form. And I know that there are going to be some assumptions built in there, but how do we help, I think members of this task force and broader stakeholders understand the impact of the potential spend that we might be recommending as we discuss at next meeting. So I'm thinking about things like, immediacy of some of the projects, like the impact of immediate spending on some of the projects that we've got proposed. First, spending some money on the water detention basins, as we've talked about, where maybe it wouldn't be as heavy as an investment threshold, could have a broader impact on residents, but maybe is also a longer term type of proposal. So I don't know exactly what factors we'd want to include in there, but maybe that would be helpful in framing how we think about the discussion next time we get back together.
I think that sounds real good. I like the suggestion.
And I agree with that completely. I think that the problem we've run into in the past is putting a lot of time and energy into kind of those, we did have a huge scoring matrix of immediacy and, urgency and, how quickly it was going to get worse and how bad the problem was and, on and on and on. And we just kept running into, and we don't have money to do any of them. So I think, the only counter to that is kind of not starting with, let's look at the world and figure out what we'd like to do. And then, keep getting down to, well, we can't afford that. We can't afford that. We can't afford that. So it's kind of a little bit of a, maybe we can think of it in terms of timeframes or something, so we don't get, distracted and bogged down. For those of us that have been on the committee for 3 years, I think that pretty much describes the first year of what we did, was just, talk about things that weren't feasible. And so, I just don't want to fall into that trap again, but I appreciate I think, we do have to be able to not only make sure it makes sense to us, but also be able to explain why we're doing what we're doing to other people and, convince them that we're being responsible with everybody's tax dollars. So maybe a starting point would be, I don't know that we've sent out I don't even think some committee members have probably even seen the scoring matrix we used once upon a time. So maybe just distributing that so people can have a look at whether that's, kind of what you were talking about, or whether that's, not it at all. And we need to, go back to the drawing board. So I think it doesn't hurt to send that out, and we'll see if that gets us part way there.
Okay, that's great. Yeah, not that it was a novel approach. I just we have gotten into that place where we felt like we've gotten aligned and we didn't have funding. Now we find ourselves maybe with a little bit of funding, and just want to make sure that we're aligned on how we're allocating that.
Yep, I like it. All right, Mr. Vunich, you want to talk any more about the grant stuff?
Again, the task force had asked that we contact the cities of Frontenac and Valley Park, 2 successful applicants to the ARPA program administered by the Missouri Department of Natural Resources. The Department of Public Works did contact them. We've yet to receive any information. So again, once we do receive it, we'll pass it on to you and we'll make sure it's on the agenda of the next available meeting.
All right, and then is this other document in here just kind of like a for information thing with the costs and things in here?
Yes, again, if you're talking about the matrix, that's just an update. If there are any questions, we'd be glad to try and answer them, that being Department of Public Works and Planning.
Cool. Mr. Sturman, I see you got your hand up.
Yeah, so that I understand it, Joe, are you speaking of, we're speaking of the ARPA fund distribution perhaps, and you're asking the 2 cities of what they did to be successful? Is that what the question is?
Yes, Mr. Sturman, the task force wondered why with 5 grant applications, none of them scored very high. I think Mr. Ron and Mr. Brown did a very good job of explaining that it was kind of tilted toward low to moderate income areas. But then we realized that Frontenac and Valley Park had received one. So the task force just wanted to kind of get an understanding what was the successful formula that they applied. And maybe if ARPA funding or other funding becomes available, we use that same formula in the future.
Well, I'm glad, and that's something I was gonna bring up, and I'll make this quick about it. I think that ARPA thing is still, the distribution is really stuck in my craw. It seemed to me when I looked that over is bizarre and blatantly unfair. $5 million goes to Ladue, the richest municipality in the entire metropolitan area. And then you go down to Springfield, Missouri, has got 14 line items totaling almost $14 million, are just 2 examples. And I guess also Frontenac or Town and Country, which aren't exactly impoverished, was also included there. And then you come along with our tremendous requirements in the city of Wildwood, and they didn't even let us in the ballpark. And I asked myself, how can this be? And what I'd really like to know is the people who made these calls and awards and their rationales, or if there's politics involved in this thing that some people knew how to use, that perhaps we didn't. I'm not out to criticize anybody, and we get left empty-handed. And that whole thing has been on my mind since the evening it was presented. And so anyway, I sure would like to know a lot more about that, because again, it just looked blatantly unfair. That's my 2 bits on that.
Well, Mr. Sternum, with the chair's permission, we are investigating those successful applications in the St. Louis County region. And certainly we have a legislative assistant, Jake Silverman, and certainly I can ask Mr. Cross, our city administrator, to contact him and just see if he knew of any particular reason or reasons why success was granted to some communities that, in our opinion, may not need it, and then why some got so many when the distribution could have been spread further around. We'll do our best to answer your question.
I appreciate that. And may I also ask, was Mr. Silverman in there swinging away for us in this process, if I may ask? I don't know if did I come through?
Yeah, you did. I think your mic
Oh,
didn't
okay.
work. That's
Okay.
I know Mr. Silverman is an effective leader, legislative assistant for us. He's been very active. I'd have to defer to Mr. Cross, our city administrator, to know the exact details on this ARPA funding.
Yeah, I was going to say Jake's been doing a good job for us. I think it might be helpful, at least it would be helpful, I think, for the council too, but for the task force, if we could get maybe Jake to just kind of write up how that process played out. It's certainly possible that it played out in a part of the government that he doesn't really get to interface with, but it would be good to know who the stakeholders were in that for sure. Because I'm betting there was a little bit of pressure put on somebody somewhere. All right. Anything else anybody would like to discuss this evening? All right, Mr. Vunish, you got anything else for us?
No, just thank you all for attending. We appreciate it.
Yeah, absolutely. Would anybody care to make a motion to adjourn this evening? We could just hang out staring at each other. Either way works for me.
I will, so moved.
All right, Mr. Sturman with the motion to adjourn. I don't think we even need a second for that, do we? Oh, perfect. All right. Well, thanks everybody for coming out. We'll have another meeting here in, what do you think, Joe? About 8 weeks or so?
Yes, sir.
All right. 8 weeks from now, we'll see each other again. All those in favor of adjourning, please say aye.
Aye.
Aye. Anybody want to hang out? All right, we'll see you all in